Okay, so Leetcode practice time. It's really late, so probably the last video, the last question for tonight. So two goals. One is to find the solution for this question, and the other one is to see how to solve this problem during a real interview. So let's get started. Usually the first step in a real interview is to understand the problem and clarify the question if you have anything that is unclear to you, and also think about the edge cases. So binary search tree iterator. Let's read through this problem. Actually curious to see which company is it. Okay, Facebook is the top one. So implement the BST iterator clause that represents an iterator over the in-order traverse of binary search tree. Okay. BST iterator initialize an object of the BST iterator class. The root of the BST is given as part of the constructor, so the pointer should be initialized to a non-existent number smaller than any element in the BST. Okay, so another API is has next returns true if there exists a number in the traverse, so to the right of the pointer, otherwise returns false. And next API moves the pointer to the right, then returns number at the pointer. Alright, so notice that by initializing the pointer to a non-existent smallest number, the first call to next will return the smallest element in the BST. Okay, and you may assume that next calls will always be valid. That is, there will be at least a next number in the in-order traversal when next is called. Okay, so it's guaranteed that when next is called, it's not the end of the traversal of the tree. Okay, so that is some kind of edge cases. If the interviewer doesn't say that next call is always valid, better to ask before the interview to see what to do, either like throwing exception and something like that. So some constraints. The number of nodes in the tree is in the range of 1 to 100,000, and the value is between 0 to a million. So at most 100,000 calls will be made to has next and next. So could you implement next and has next to run in average O1 time and use OH memory? H is the height of the tree. Okay. So let's see. I would say if has next and next, the API call is definitely the concern, which means you want to make it run as fast as possible. Then we can do a in-order traversal of the BST and store the result into into an array or a list. Then then we can just like iterate through an array when has next or next is called. So that one, the space complexity is definitely going to be linear to the number of the nodes within the tree. And for the runtime, for the constructor, since we are going to do a whole the traversal of the tree, it is going to be linear to the number of the nodes. But for next and has next, it's gonna be constant for runtime. So that's the first solution. And the second solution I can think from the top of my head is you can do the traversal of the tree while the next or has next API is called. But it is better, actually, we need to implement the non-recursion version of the other traversal here, which means we are going to use a stack to solve this problem. So for this one, the runtime for the constructor is going to be linear to the height of the tree, and for the next call, it is going to be it's going to be linear to the height of the tree as well. And also has next is also okay, so has next is going to be constant regarding the runtime, and for the storage it's going to be linear to the height of the tree, which is OH. So considering that, for the two solution, I would say the second one, the first one is very easy to implement, just using the recursion to do over the traversal of the tree. The second one is a bit, it's a little bit more complex. So I would say to practice the coding, we will start with the second approach. So after we find the solution, we do runtime space analysis, and it's time for us to turn our idea into solid code. So in this part, we care about your correctness, the readability, and of course the speed. And also it says, could you implement next and has next to run in average of 01? So in average of 01, I would say yes. Yes, and use OH, which OH memory. Yeah, so that one, that is as we said, so OH of time, we need to use a stack to store it up to like H nodes in the stack. Regarding the average of 01 runtime, has next is definitely 01, and for next, I would say average if it is called n times. Yeah, so in average it is constant, but worst case is still like OH. But I would say that would be the best thing I can think about currently. So let's get started and do some coding work. So first of all, we are going to define a stack of the tree node. So let's say, let's just call it stack, okay? And in the in the constructor, the first thing we are going to new the stack here, and we need to push all the nodes from the root and all the way. So we are always going towards the left child and keep pushing the nodes into the stack until we hit a non-pointer. So since this one is also going to be used in the next function, we can define a helper function. Let's see, it is void. Let's say visit left pass, and input is a tree node as root, and what we are going to do is we are going to see, well, root is not equal to none, then we are going to push it. So stack dot add root, and root is equal to root dot left. All right, so here first we initialize the stack, and then we are going to push, we are going to call visit left pass to push all the nodes from the node. So we are going to go through the left pass to push those series of nodes into stack when we try to initialize it. So for the has next, it is pretty easy. It is just going to return whether it is empty. So it is going to be not stack dot empty. Okay. So regarding next, what we are going to do, so we are going to pop the top element from the stack, So it says that the next call is always going to be valid. So you may not need to really care about like store exception, whatever, something like that. So first of all, we are going to say, okay, tree node, the top node is going to be stack.pop, and from now we are going to go to its left child and call with the left pass and pushing those series of nodes into the stack. So if top node dot right is not equal to none, then we are going to visit left pass top node dot right, and finally we are going to return top node dot what is that, top node dot okay, top node dot value. Okay, so that's pretty much it for the code, and after we are done with the coding, it's time for us to do some testing. So two parts. The first one is to do some sanity check to explain how this piece of code is going to work given a example, and then we think about some test cases to try to increase the test coverage. So let's say first of all let's take this example. We first initialize the constructor. We call the constructor to initialize it. We are going to have a new stack, and we put 7 3. So first of all we put 7 and then we put 3. So the top element currently is 3 in the stack. And then suppose we call next, then we are going to pop 3 from it, and since the right child of it is empty, is non-pointer, then we are not going to visit the left child. So we are going to return 3 here. If you call another left, we pop 7 from it, and then we are going to, since its right child is not equal to none, then we are going to visit we are going to push 15 and then 9 into the stack. And then if we call has next, since stack is not equal to empty, then it is return true. So then we call next, we say okay, we pop 9 from the stack, and at this time it doesn't have a right child, so not to visit left pass. And then if we call has next, then it is going to return true. Then we call next, then it is going to pop 15 from it and add 20 into the stack, so on and so forth. So at this time I think we should be good with this piece of code, and let's give it a shot. So compare arrows. Okay, so it's a typo here, so it is root. Alright, so it's accepted. Let's submit this piece of code. Okay, so it is succeeded. Okay, so like I said, one way to do it is in this way, like something like implementing a non-recursion version of the in-order traversal of the tree, of the binary tree. So the other one is to do a in-order traversal in the constructor and save the outer number into a list, and then we can just like iterating through an array of next, or has next API is called. But it's just some trade-off between like space and time, and also some trade-off like the time complexity of the API implementation. So that's it for this coding interview. So if you like it, please give me a thumb up, and I'll see you next time. Thanks for watching.